Absolutely nothing. And we're live! Alright, so we've got this so far. Great. But that doesn't still tell us anything about the pink triangles. Not yet, anyway. Zayden, what else?
You can use angle addition postulate to get the angles that you need inside those triangles.
Right, so check it out. See how these light blue angles are the same? And these dark blue angles are the same? Well, if I take the light blue angle and subtract the dark blue, I get what's left over, right? Same thing here. Light blue minus dark blue equals what is left over. So the part that's left over must be the same. Does everybody see that concept?
But we still didn't know the name, so we couldn't write.
That's what you saw?
Yeah, but
I
she
didn't
knew
know
the
the
name, so we
name.
couldn't
Angle
write.
addition postulate. So when we have pieces of segments or pieces of angles,
Yeah.
you're going to want to use the addition postulates. So we know that means DAF, that angle, is congruent to angle EDF. Go. My congruency signs are getting lazy.
Do you want to raise your feet?
All right, so now we at least have one of the angles of the pink triangles. What else can we get? Go ahead.
For the bottom, the triangle at the bottom, you can use the converse to get the side.
Exactly. It looks like everybody in here is getting really good at spotting the isosceles triangles, right? Two congruent angles means we have two congruent sides, right? The opposite sides. So we're going to say by isosceles triangle theorem converse, because we started with the
But
angle.
we solved
right?
that problem, right?
We know that AF, is congruent to BF.
If we would have started it right, we might have.
Okay, so we know that. Now I've got an angle and a side of both pink triangles. What's the last thing I can get? Go ahead, David.
Vertical angles.
Vertical angles, baby. Right here and here. So by vertical angles theorem,
We had this though. We got them.
we know that angle DFA is congruent to angle EFB. All right, so now we have all the information we need to prove the triangle's congruent, so let's do that, and then after we prove them congruent, we're done. So, what do we got here? Angle, side, angle is what I'm looking at. Triangle ADF is congruent to triangle BEF. That's exactly what they wanted. Done. How do you feel about that? Dece? Anybody do it a different way? Did you attempt it?
We did it a different, correct way.
All right, another way you could have done it. Oh, Zayden, do you want to walk me through it or no? Okay, hold on 1 second. Let me draw another diagram.
Did you want your eraser back?
No, not yet.
All right.
The future is still dark.
That's true.
Yes. All right, so we have a diagram like this, and we were given
I will definitely move myself.
A,
Yeah.
B, C, and D, E, F, and we were also given these were the same, and that these were the same. Right? So we get that for free. Assuming. All right, Zayden, walk me through how you would solve a problem like Maria, but differently. What did you try?
I drew a perpendicular line all the way down from C.
Yep.
And then I just said that both those angles were 90 degrees, or I could just do 90 degrees and then
Yep.
the other one's LPT.
Okay, so we got that. So we're gonna say let C. Let's make it like this. Let's call it a G. So let CG be perpendicular to AB. Okay.
And then I did shared sides for the line that goes from F to G.
Okay. So okay. So my one critique is that when we draw that line, we are assuming it goes through the middle here.
Yeah.
So what we should probably do if we want to use this is just create a line from that dot down.
Yeah.
Does that make sense?
Yes.
So the way you're doing it, forget this. Let's write it differently. Let's say let FG be perpendicular to AB. Is everybody cool with that? So we're just gonna have this line right here. Forget this top part. All right, so let that happen, and then now you're saying we have a shared side.
Yes.
So we've got shared side here. So by shared side, FG congruent to FG. Cool. And then what?
And you should have enough for AAS, which will solve both of the triangles equal.
Okay, so those two triangles down at the bottom are congruent because we have angle, angle, side. And now what are we going to do?
And then you can do the vertical angles for angle DFA and EFB.
Okay, so we're using the same vertical angles as we did last time. These two. Whoops, that's a B. Hey.
And then I did the same thing with the Isosceles triangle theorem. So I got angle CBA and angle CAB are congruent, and then I did AAP to get that just the angles inside that triangle are congruent.
All right, so he's going to say real quickly, I'm not going to write this down, but he got those two angles based off these two sides, right? Isosceles triangle theorem, so those two angles. Then what's left over must be the same. So same thing we did last time. And then what he's going to do is say, by CCP, this side and this side must be the same because those two triangles are congruent, which means their parts are, right? And now we've got angle, side angle. Cool. Red. Put that away. Actually, don't put that one away. Get out of 10. This one's going to be on your own again today. Do the best you can. EG and BG are the same. So that's this guy right here and this guy right here. Notice the tick marks only apply to those little spots, right? If we want to go across breaks, then we use squiggles, which we're going to use in a second. We know that AE and BD are the same. So that's true. And we know BC and EF are the same. That's where we're going to need the squiggles.
What?
I know.
What?
BC
Can you just draw like it's a one?
and EF are the same.
That gets confusing.
We're going to prove that the two angles C and F are the same, these two guys. So those angles are part of these two triangles. So if we prove these two triangles, the big right triangle and the big other right triangle, although we can't assume they're right, they look right. Those two right triangles, right side and left side, we can prove these two big guys the same. Then we'll have their angles be the same by CCP. Right now we have one side of the triangle that matches, right? Here and here. We need to get some other angles on other sides. This one's a little tricky. You're going to have to use segment addition postulate, but in kind of a different way than we can use it. Best of luck.
Okay.
Work together.
Okay, wait. Bicep.
On purpose, I got done.
I think we can do this. This is what we did last time, and we went on to bicep. Bicep.
Won't think I am the road work guy from the road work vine. I am Drew, I am Danny, and we are not.
This one is bicep. Because these have to be so bicep.
I am Drew, I am Danny, and we are not the same person. We may have similar lives, we may have similar wives, but we are different nonetheless. And if you took the time to get to know us
I think we can do that this
for
time.
a minute,
We did last time when we went on a trip.
you'd see that I'm Drew, and I am Danny. Yes, I am Drew, and I am Danny. My hair is brown, my hair is hazel. Look at our faces, look at our nasals. Why can't you see all the differences that I do? My eyes are baby blue, My eyes are a different shade of baby blue. People say our videos are similar just cause we both make videos about Lele Pons, Logan Paul, TikTok cringe, bad life hacks, Instagram comedians. People say we copy and agree a lot. I don't see it, yeah, me neither. Dreaming of a day that the commentary genre will be all mine, mine, all mine. And I'm dreaming of a day people won't think I am the road work guy from the road work vine. I am Drew, I am Danny, and we are not the same person. We may have similar lives, we may have similar wives, but we are different nonetheless. And if you took the time to get to know us for a minute,
What about a line?
you'd see that I'm Drew, and I am Danny, and I am Danny, and I am Danny. Why does nobody talk about how hard it is to be a skinny white guy on the internet? Why are there so many white guys on the internet? Can someone get all these white guys off the internet except for me and me? People think I copy Danny's videos. People think I copy Drew's videos. Why can't you get we don't copy each other's videos?
Well, they are.
We copy Cody Co's. Dreaming of a day when I don't hear people say I'm a knockoff Drew, knockoff Drew. Dreaming of a day when you die in a fire and I get all your subscribers. I am Drew, I am Danny, and we are not the same person. We may have similar lives, we may have similar wives, but we are different nonetheless. And if you took the time to get to know us for a minute,
The Lions are bad
you'd see that I'm Drew, I am Danny.
Whoa, where the fuck did that come from? Yeah, what the fuck was that?
What song is this? This is amazing. I figured it out. Yeah. Maybe. Probably right. Okay. So this little thing's a triangle.
No.
So this has to be congruent right there.
Alright, so here's my logic. I don't need to write this
That and
down,
these
but
have
I'm
to be
just gonna
congruent,
show you
right? By
that it
something.
makes more sense.
Because the sides.
So I know that AE
Well, because
plus EB
Some way we prove this triangle congruent, and then we can.
is gonna equal.
Because if that triangle is congruent,
Okay.
I completely lost my train of thought. Wait.
Cool.
If that triangle is congruent,
And I also know that BB, which I'm gonna do in purple as well because these are congruent, right?
yeah. So when this triangle is congruent, then we can get this angle, which will give us side equals side, which makes this congruent by SAS and this congruent by SAS.
Alright, so
And then that would get us the angle.
if purple
Okay, so
and
then
red
start small.
equal
So all we have to do
that, then
is figure out how to make this triangle congruent.
I get it.
Does that make any sense?
I have 112 to see.
I'm gonna say
I feel like we're just going to be wrong again.
Yeah, I
I'm
have a
really
feeling.
disappointed.
segmentation says that I can take the middle part of it and I can say it's right? And then I can switch out these values and I got
Yes.
right? So we're just gonna call it segmentation population.
They don't figure it either. Erica's like, okay.
Okay, wait, these sides are the same.
So now I've got side and
Okay, so we're trying to figure out the small triangle faster.
side.
Yeah.
Okay.
Or at least this one.
I don't know. Well, we said that. Well, it's given that EG and like
G and GB are congruent.
yeah. So then
We just need one angle.
A is made up of this big side right here that we figured out, right?
And they have to be congruent. That will also work. But like, there's no way that.
And then B is this angle. And it's made up of the side we figured out. This big side that we're given for now.
It's fine.
Side we're given, side we figured out.
no, my grades.
Let's see this class right now.
C.
Really?
That angle.
Is that one homework assignment I had?
I didn't see the list do.
Actually, the same assignment that I told her to do yesterday.
We don't do C and everything. The reason we
Yeah, I got 73, so like my grades a little lower right now.
So our grades basically like 6% off.
Why is that? How? What?
that says that
But this triangle has to be congruent.
then we're allowed to take the part.
Why though? We have to.
Oh, and C is the same, right? You can't do it.
Wait.
What?
It's only the corresponding
How can triangle be congruent to itself?
So notice that C.
That doesn't even work out. There's not another triangle to prove congruent.
We're allowed to say that.
That literally makes 0 sense. That's for algebra.
No.
Well, that's
How do you
super
feel
useful.
about
Wait.
Okay, all right. We're gonna back up over again. Right? This side, this segmentation postulate,
Okay.
purple and red.
We already
Purple
used
and
that.
red.
So we can use it again.
Are you sure?
Side angle side, side.
So bisect.
Side.
Wait, well
Side,
first,
angle,
it's
side.
not a,
On the left, I did that.
it's not one of those
corresponding
triangle
parts
things, 'cause
match
it's not
up.
a triangle, right? But can you break it off?
I don't want to draw a line.
FED. Wait, FED and CGA.
That's better.
Right.
That's,
We need to somehow get those two congruent.
yeah.
That's why I was trying to get this little one.
And by back, I mean I'll be back later, but that's it. You did. You're done.
Because that would make
Who's got a question for me?
that would make it. If we get this triangle, that has to be congruent. But this
Oh
triangle.
god, don't draw an extra line. You don't need to draw an extra line. Don't make it worse than it already is. Okay.
Okay, so we wasted the first half of class drawing for
You can draw a line right there if you want.
Oh.
Yeah, you can do that, but why would that?
Because it makes triangles.
It does, but does it, do you have any triangles that are congruent?
Okay.
Yeah, you can prove. How would you know?
Wait. I have totally figured
You can
this out.
figure out
Have
this
you
side
now?
by segmentation
Said that?
postulate.
Totally.
That side, you have that angle, the other triangle would be congruent.
These
And
sides
those two angles would
are
be congruent. Right? Full angle,
by
full angle. You see what I'm saying? So,
corresponding.
you would eventually, here's what would happen.
Cap?
You would say angle, side.
Wait, so
right?
GED.
Yeah, you have side,
Are you
angle,
talking
Angle
about
E and
the,
angle B.
yes, congruent.
Like
By
that, right?
segmentation.
Because they're
Right.
corresponding angle. Did I
Right.
say
So,
corresponding?
you have side
Is
and
that
side,
even right?
which means their angle is congruent, right?
We're doing-
The problem is it's not the full angle. Right? And so you have to figure out if this was the same as well. So you prove these two triangles are the same. They share the same side because these parts are congruent, right? So,
But it's really
They are
yeah.
They are not corresponding.
These sides. You prove those sides the same, but I don't know how to do that.
Okay, can't put that part. Because we get this triangle to
But it's not a bad side. Alright.
We kind of figured this out, but we're missing like one step.
Okay.
Yeah. Okay. So if we get this triangle, then we can make this.
Those two angles, yes.
We can get this to match this, which will make these congruent by CCD.
So here's the deal.
These have to be congruent. I don't know by what. Like I don't know what the angle.
Well, that's the triangle, isosceles triangle theorem, right? If you have the two sides, you get those two.
Okay.
So there's the angle. You know these are the same, right? Because that was given to you. So there's side angle. And then if you can get that side, you want it.
Yeah, I think. Okay. So by isosceles.
there you go.
Alright.
I couldn't think of it either, so like.
Alright, you guys ready?
You must like what we learned yesterday. Isosceles angle
Oh, yeah.
B is congruent to angle B.
Alright, so
Oh no. Wait.
first off, I think a lot of you guys saw this, which is great because seeing it is important and getting as much information down is good. But it's not going to help you get it done. So let me show you one thing that everybody seemed to see, but ended up not being useful in the end. So a lot of you guys said, see how these reds match, right? And these greens match? Well, if I know red minus green gets me what's left over, red minus green will give me the same leftover over here, right? That's segment addition postulate. So it is true that CG and FG are the same. It's true by segment addition postulate. However, that segment right there isn't part of a triangle, is it? Right? It's part of a quadrilateral, a four-sided thing. So that's not really going to be useful. It's true that they do match, but it's not going to be useful. So I'm not going to waste my time with it. If you wrote it, that's fine. Nothing wrong with that. Nothing wrong with that. But it's not going to help me prove these two triangles congruent. I've already got this side down. I'm good, right? So what I can do, and a lot of you guys did see this, and this is helpful, is that these two angles must be the
It
same,
doesn't work because we haven't given this is congruent.
right?
Because that's part of.
So these two angles are the same. How do I know those two angles are the same?
Wait, no.
By what?
Congruent by CCP. All good.
The theorem.
EB is congruent by CCP.
I'm going to write angle GEB is congruent to angle GBE. So now, for my big triangles, I have a red side and a green angle. I just need to get this other side, and then I can do side angle side.
Congruent to itself.
I'm not going to be able to prove these sides are the same. Even if I did, I get ASS, right? And I'm not going to be able to touch those angles. I don't know about those, right? I'll never be able to figure it out. But I can prove that this side here on this triangle is the same as this side here. So I'm not going to color them in with any special color yet. I'm just going to highlight it so you can see what I'm talking about. This side here, I'm going to prove to be the same as this side here. You dig? Now, I can't just say that they are. Here's how I'm going to do it. While it is true that this side right here isn't congruent to anything necessarily, I'm coloring it in orange so you can see what I'm talking about, okay? So I'm going to talk about that side. So follow my logic here. You don't need to write this. We're going to cut to the chase in a second. So notice that AE plus EB makes up this whole segment that I'm trying to talk about, right?
Yes, that's right.
AB. Are you guys with me on that? Make up this. Same logic for this side. BD, which is also in blue, because it's congruent to AE, plus the same middle part equals this other side. So here's my logic. If orange and blue equals this, and orange and blue equals that, remember these are the same thing, right? Then these must be the same. So therefore, AB congruent to ED. So we know these two sides are the same. You did? David, you see what I'm saying? Kind of. So this side right here of the triangle is made up of a blue and orange part, and this side over here is made up of blue and orange, so they must be equal.
Okay.
Right? I marked it orange so you could see what I was talking about, but that's segment addition postulate, okay?
It's right.
Is Landry getting these all right? And Luke's like, no, we can't do that yet. And then Landry's like, yeah, we can. See? Is that how it's happening?
Totally.
Good. So AB is congruent to ED. So now we've got red side, green angle,
I don't know.
and then navy side. So red, green angle, and then navy side. We've got side angle side. So by side angle side, the two triangles are congruent. So triangle ABC merge triangle looks like DEF in that order. And if the triangles are congruent, then their parts are. So now we can say that angle C is congruent to angle F. And we know that because, look, C and F are corresponding, right? So by CCP, angle C is congruent to angle F. And it's because they're corresponding. How do you feel? Where are you getting stuck? Did everybody see the green angles are the same?
See, that's exactly.
Yeah? So we got that part? Green angles? David?
First step in
Yeah.
this.
Then by SAP, that was kind of the weird one, right? That these
Wait, is
two
it?
segments must be congruent at the bottom, right?
Oh, no.
AB and ED, right? Overlap. SAP, 90% of the time. Look for the overlap. I think tomorrow what we're going to do is play spot the stuff. We're not going to do full-blown proofs. I'm going to give you a diagram, and I'm going to say, look, there's a chance to use SAP here. Where is it, right? And we're going to find out where those chances are so we're used to seeing where it is in a diagram, okay? That's going to be the goal. How do you feel about that? Feeling okay? Okay. Let's do an easy one and then a not so easy one. Number 8. 8 is easy. It looks hard, but then once we do it, you're going to go, oh, that's dumb. So coordinate proof is when you're using a coordinate plane to prove something. Basically, it's geometry, but you're allowed to measure because it'll be drawn to scale. which is like cheating basically, right? How do you know that all of these are equilateral, right? Look, how do you know this is an equilateral triangle? Oh my God, how do you prove it? Well, you measure it, and it is. Done, right? Geometry's like, nope, can't do that, it's not drawn on scale. Right? Deal with it. Coordinate geometry is just like, oh, I'll put it on a grid. Look, I can measure it. Done. It's like the geometry you wish you could do, right? So, A is at 7, -1. That's right here next to my mouse. B is 2, -2. And C is 3, 3. So I'm going to connect those and make a triangle. Fun fact, if you have 3 points, there's only one triangle you can make. No matter how you connect them.
Wait, so can you just use like the
So we can use distance formula and plug in those coordinates, or, right, we can do the distance formula, but we know distance formula is the same thing as Pythag, right? Pythag is what we can do when we have a picture to work with, right? So let's just do Pythag. Check it out. If I make C and B into a right triangle with my grid, that's 5, and this is 1. So by Pythag, the distance between B and C, right, that hypotenuse, will be 5 squared plus 1 squared rooted. So I'm going to write by Pythag, CB equals the root of this stuff squared. 5 squared plus 2 squared, or 1 squared. Which is going to equal root 26. 25 plus 1 is 26. And I'm not going to waste my time with CA, because look, CA, if I were to make it into a right triangle, is a 4 by 4, right? That's not the same as this. But I do notice that BA is a 5 by 1. So they're going to be the same, right? Therefore, BA is congruent to CB, right? And if that's true, do I have an isosceles triangle? Yeah, 2 sides are the same, BA and CB. So by definition, triangle ABC is isosceles. Done. Not too bad, right? You can even prove something isn't isosceles, right? Measure all the sides, and if 2 of them aren't the same, then, oh, look, I've proven it's not isosceles. This is hardly geometry, in my opinion. But if you see it, which you will a lot, because testing companies don't know how to actually do geometry because it requires actual thinking and thought, and how do you measure that with a multiple choice test, right? You'll see this in the geometry section of the SAT and crap. Isosceles, yes or no? Yes. Good job. You know a definition. If someone hadn't told you what isosceles meant, you wouldn't know it. Therefore, you were smarter than other person who has never been told that. Right? This is stupid. This is stupid. Everything is a waste of our time. All right. So here we go. There it is. I'm moving on. I did it. I showed you it. 7. Before we do 7, let's talk about a blast from the past. Okay? You're not going to really need it too much for this, but we need to know it because tomorrow we're going to do some more examples similar to number 7. All right, so if I have 2 lines, yeah, go to the game tomorrow. Erica, go to the game tomorrow. Erica!
I can't.
Erica sucks. She has other commitments, but she still sucks.
I know.
And we're live. All right.
Yeah, on your way home.
Yar, do you remember this? So if L and M aren't parallel, then like there's nothing really special here, right? But if L is parallel to M, what does that tell us?
Transversal LPT type thing.
LPT is always true, guys. Even if they weren't parallel, right? Here's an example of lines that aren't parallel. Are those two angles going to add up to 180? Yeah. Oh, sorry. Those two lines aren't parallel. I'm so happy to see you. Those two angles are going to be LPT, right? Are these two angles going to be LPT? Yes. They're not going to be congruent to one another, but they are going to add up to 180, right? So that has nothing to do with parallel, right? Same thing with vertical, right? Any two lines that intersect are vertical angles. So that's not special. What's special about two parallel lines?
Corresponding angles.
Corresponding angles. Then the corresponding angles are congruent. This is a postulate. We call it corresponding angles postulate, right? If that's true, then this is true. We just know it to be true. What are corresponding angles? Angles in the same relative location. So those two angles would be the same, right? Only true if the lines are parallel. Now the question is, does the converse work of this theorem? And by theorem I mean postulate, right? It's the cap, corresponding angles postulate. Right? Shout out to Danny, we cap. All right, so is this going to be true in reverse? Meaning that if we have these, then we can say these are parallel. And the truth is, yes, it does go both ways. If those angles are the same, then that means these two lines are parallel. So we're going to say the converse of this would be if the corresponding angles are congruent. Then L is parallel to M. This is cap, but the converse. Okay? So keep that in your back pocket. That's something we can use. We can prove two lines parallel if their corresponding angles are congruent. So if these two match, then those two lines are parallel. Last year we did if these lines are parallel, then those must match, right? But it goes both ways. The converse is true for this postulate. Remember? Corresponding angles postulate. Okay. It says if the two lines are parallel, then those two are the same. The reverse is always also true, the converse. If those two corresponding angles are congruent, then these must be parallel. Okay, so moving on, let's look at number 7. First hour destroyed this, although first hour's been destroying things lately. Normally third hour, fourth hour is my best show, but first hour is just really kicking it up a notch. Sorry guys. It's because Luke's gone. Yeah. Alright, so let's write down what we got. It says that AR, B, and TSC are lines and that they are parallel. So let's make some parallel symbols. This line is parallel to this line. Okay? We also know RT bisects BRS. So let's find angle BRS. BRS is this angle right here, this big angle, right here. BRS. And it's saying RT is bisecting. Remember, bisect means to cut into two equal pieces, right? Bisect. Sect means cut, like sector cut rock, right? And then bi means two, right? So we have two equal pieces here, is what it's saying. So that means this must be the same as that, because RT is cutting this big angle in half. Is everybody cool with that idea? Big angle here, BRS, is being cut in half by RT. That's what bisects means, right? So those two are equal because they're both halves, right? You with me, Luke? Right. It says M is the midpoint of RT. So here's RT. M is its midpoint, which means that these two must be the same, right? Here's what we're trying to prove. That SM, this line right here, bisects RST's angle. So we're trying to prove that this angle right here is cut in half by this segment. Now, how do we prove something is a bisector, or that it bisects something? We prove it if those two angles here and here are the same, right? So we're going to prove that this angle is the same as that angle, and then we win. So we're going to prove that RSM, that angle on top, is the same as this angle on the bottom. If we do that, we win. That means this guy's bisecting it, right? Don't be confused by what this is asking, right? It bisects it if those two angles are congruent. Now, notice those two angles belong to two triangles, right? The top triangle and the bottom triangle. So if we can prove the top and bottom triangles congruent, then we can prove their angles congruent. We win. Now, right now, look at those two triangles. Do we have enough information to get it done? We've got an angle and a side, and then just a side down here. So we need to get some more information to prove those two congruent. Now, Luke said, I see a shared side. I think if we played the spot the shared side game, I think you guys would all be very good at it right now, right? We'll play that tomorrow, very briefly, and then we'll move on to bigger fish. But in general, I think we're good at seeing the shared side. This triangle and this triangle share that side. So we're going to say by shared side, SM is congruent to SM. SM's used for both triangles, is what we're saying. Xavier, you with me? Yeah? Okay, cool. What else do you see that we can put on here? Yeah?
We can extend line CT and extend line RT, and then we can use cap to find that angle, the other angle T.
Yep. So shout out, I'll stop you there. Shout out to Taylor Swanstrom in first hour who saw this. It was really great. If we extend this out, and we extend this out, notice how we have two parallel lines being cut by a transversal, right? So how do we make that happen? This is a let there be line thing, except we're going to let there be points. So we need to label these points and say we're extending it out to there. Does that oh, let me zoom out, sorry. We're going to extend those lines out to those points, okay? So we need to call those points something. In first hour, we called them J, K, and L. So I'm going to call them J, K, and L now. So here's how you say that. Let there be a line. And what line? It's going to be line CSTJ. That's what we're creating there. Now again, I labeled all the points so we know all those points are collinear, right? All of that is one continuous line, okay? And then we're also going to say, and let there be line LRMTK. We can do that. R, M, and T were already lines, so we can say that LRMTK is also a line, okay? Are we cool with that? So now that we've extended those lines, which is something we did last year, right? But we never really wrote it out. Now what we can say is these angles here and here, this blue angle and this blue angle, right? This blue angle right here is the same as this blue angle down here. How do I know that these two blue angles are the same? Cap, exactly. So by corresponding angles postulate, which says if the lines are parallel, which they is, right? Then those two angles must be the same. They're corresponding. So we're going to say angle BRM congruent to angle JT. That's a T there. Okay. T's right here. Okay. Now, great. That angle isn't part of any of our triangles, right? It's not. So why did we do that? What does that get us for our triangle? Zaidi.
Gives us vertical angles there, so we can get that underneath.
BAT, baby. Vertical angles gets us that. So that's angle MTS. And we're going to say that's going to be congruent to angle MRS. Oh, no, sorry, not MRS. JTK. The angle we had earlier, right, by vertical angles. Those two angles are congruent. Now, we've got angle, side, side. Ah, it's ass. We've got ass. Hey, when that happens. That's the problem. So, these aren't right triangles. We can't prove that. I'm going to tell you right now it's impossible to do. You can't prove those are right angles. Not yet. Okay? We need to have information about these angles first, and then eventually we can prove that it's right angles with the theorem we haven't learned yet. But we need those angles first. And we're not going to get those because that's what we're trying to get, right? So we're not going to get those right angles. It requires knowing these guys, and if we knew these guys, then we'd just be done with the proof, right? So, how am I going to get other information? Go ahead.
It's an isosceles triangle.
Killed it. All right, so check it out. Jess sees an isosceles triangle. these two angles are the same, right? Which means this whole triangle is isosceles. So that means these two sides are the same. Does everybody see how these two angles go with this big triangle, SRT? Right? Good job. Don't forget to see the big picture. A lot of you guys are like, oh great, I got these two together for these two individual triangles, but you're forgetting the big triangle, right? We know those two are the same by isosceles triangle theorem or converse? Yep, because we're starting with the angle. We know side SR is congruent to side ST. So I'm going to zoom out. Okay? And now we can say the triangles are congruent. We have a couple ways of doing it. We can do side, 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 or we can do side, angle, side, right? I'm going to do side, 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 so we can use Luke's shared side. Respect. But you can do side, angle, side, right? By side, side, side. Triangle SRM is congruent to triangle. Well, S is made up of the green and the blue, right? So if I go to the other triangle, green and blue is also S. R is made up of the green and the red. If I go to green and red over here, that's angle T. And then if I go to blue and red on both triangles, I get M. So M goes with M. This is important because the next thing we're going to do is we're going to use CCP, right? And CCP is going to say this angle and this angle are the same. Because look, angle S, or MST right here, MST, third, first, second, it's the same as third, first, second over here, MRS, oops, sorry, not MRS, MSR, MSR. So angle MSR is congruent. Again, MSR is third, first, second, so it should be congruent to third, first, second over here. Third, first, second, MST, MST, MSR. Checks out. Now, we're not done, because they wanted us to end with the statement SM bisects RST, right?
Wait, why do we even need the angles? Can't we just do it off of the fact that those two sides match?
No, bisect means to cut this big angle in half.
Oh, okay.
So we need to prove those two are equal halves, okay? Good question. So now we're going to say by definition, that's a bisector, right? An angle bisector.
Yeah.
So SM bisects RST. We're done. All right, I'm going to back up and go over it again. Double-sided now. Okay. So, first off, everybody see the shared side? All right. Then we said, let there be extended lines. Then we said by cap, these angles are congruent, and by vertical angles, these are. Then we got these sides by seeing that this is an isosceles triangle. And then by side, 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 the triangles are the same.
He's like, okay, you guys have 27
If the triangles are the same, then the angles are the same, and by definition, that's a bisector. I'll see you tomorrow.
25. You guys have 5 minutes to write a 3-page paper and do at the end of class today.
When?
She's like, maybe
Oh,
I
no.
didn't give you enough time. You know, we'll spend
I guess I'm not coaching, boys. Sorry,
Oh,
guys.
I'm sorry. Oh, I'm sorry. It's okay. I'll grade
Unless no
it.
one's going to come up to me today and say, hey, guess what? But no, I don't think so. I sure. Who's your cousin? Yeah. What's up, Tucker? I was black. Emily's got new hair. Emily's got new hair. Great.
Y'all ever just taken a fucking trip to a really high place? You're like, I don't know what happens like fucking joke.
Hey, God, of course. What else would happen?
Oh my god, so,
someone killed them too.
so I was on art selection going to do both the other day.